Right, we'll try again, shall we? Good evening, all. Welcome to the March meeting for EMDRC. Great to see people turn up tonight. We've got a couple of visitors and we've got a new member, I think, Richard. Welcome. Good to see you here. And Aristotle, I think, and his dad are here visiting just to get the lay of the land and see what the hobby is like and what it can offer for him. So today we've got Richard VK3TXD doing a presentation on his experiments with antennas. I'd like to hand it over to you this evening and entertain us with your learnings. Thanks, Richard.
Thank you, Martin, and thank you everyone for spending a Friday night here. I hope I can offer something to entertain or help or further the hobby. And it's just occurred to me, I've been speaking to a couple of amateurs tonight. Every time I get up on air, I ask people what antenna they're running. Would you mind putting up your hand if you run an Infeed half wave? Three, okay, it's a little bit less. Normally I find it's about 30 to 50% of the people I talk to are running an Infeed half wave. Tonight's a talk on those, hence the title. Feel free to shout questions, and I've been told I should repeat them for the online listeners. So if I forget that, shout at me again. Now, this started about 18 months ago when a friend of mine said, Richard, would you build me an Anon? Now, an Anon is an unbalanced to unbalanced coupler, which is designed to couple an unbalanced system to another, typically coaxial cable to an antenna of some kind. And I've heard it pronounced un, but I call them Unans. I said no. I said they're the devil's work incarnate. You're trying to... its impedance, depending on how high it is, can be anywhere from 70 ohms to 50. If you take it down really quite low, people call them NVIS antennas. They can be around the 20 ohm mark, but typically if you go out field day or at home, somewhere around about the 50, 40, 60 ohm mark. Depending on, they're single banded. So if you put up a dipole for 80 metres, don't try and run it on 40, the impedance will be disgusting. You might be able to run it on 20, but it's typically single banded. They've got fairly low common mode current. I'll go into that a little bit later. Traditionally, to get the good signal out of a dipole, we take them up as high as we can. If you can get them up a quarter of a wavelength high, they go pretty well. Now, the highest current on the antenna is in the middle of the antenna. And if you go back to when we got our licenses, they talk about the end of the antenna's got the voltage and the centre of the antenna's got the current. You've got burns versus fire. If you touch the thing while it's transmitting. Now, I need to say my antenna modelling is naive and basic. Here's a classic example. Does this work? Yes. The feed point in the middle is the little circle, and the green line is the current profile. This is taken straight out of 4NEC2 modelling software, and it tells us that the maximum current is in the middle of the dipole. On the right hand side here, you see the blue circle, and I've got my finger over the light, that's clever. The blue circle is an indication of the gain that you could expect and where that signal is going to go. Down the bottom right hand corner, can we try and remember that number there, 6.34? That's the dBi. That's a measure of the gain of that antenna that we would expect it to have compared to an isotropic radiator. But anyway, that's an indication of the gain. The red circle is saying that it's giving that same sort of signal in all directions, so it's not directional. Now, the notes on the bottom left-hand corner, height can change the pattern significantly. There's an upcoming de-expedition to Norfolk Island, and they're putting a doublet antenna, which is basically a dipole fed in the middle with open wire. And I saw that they're taking that up 30 metres high. Wow. I did the modelling on that, and... Can I just interrupt? Yeah, go for it. Interrupt, Tom. What about that antenna is that instead of having most of its radiation straight up like this one, which is really quite low, The Norfolk Island one has the radiation more going out to the sides. So that will far better suit DX distance. Okay, so it will bounce off the ionosphere in various layers. It will give you a much better DX signal. And that's why I said, wow, that's a great antenna. And fed with open wire, it would have a lot low losses, but we're talking about Infeds. So recap, centre fed, somewhere around about 50 ohms. It's a gold standard. We compare other antennas to it. Single banded, pretty good gain. Ideally it wants 3 supports, one at each end and one in the middle, but a lot of people, they just run with one support and they bring the arms down close to ground. You lose a bit of gain, but hey, it's one support. One point I would make is that you've got to get your coax right the way up the top, or for Norfolk Island, the ladder line. Open wire fed, quite often we call that a doublet, and you need a tuner at the bottom. Quite often a good tuner too. As soon as we move the feed point away from the centre, if you move it to 1/3 of the way to one end, 2/3 from the other end, we call that an off-centre fed. That's multi-banded. So if you put up that same piece of wire, feed it 2/3 by multi-band, say if it was cut for 80 metres, so it's a 40-metre piece of wire, we can run it 80, 40, 20 and 10. No tuner. It'll be in the ballpark there somewhere. You may want a tuner just to nip it up a little bit. As we move away from the centre, the impedance goes up until we get close to the end, when we can get really quite high impedance. Anywhere, somewhere in the 2 to 4 kilo ohm range, and that's a high impedance. Someone mentioned tonight, how do you go feeding that into an auto tuner? I would suggest that you don't. With that high impedance goes a high voltage. Your auto tuners quite often will not like that. And the other point I would make is that a good Unan that you use instead of an auto tuner will quite often be more efficient. I'll talk about efficiency later. It won't matter much in terms of signal, but it certainly will matter in terms of heating and component wear and tear. My very first ever end-fed I put up, it was on 80 metres, and I was running 20 watts. It had a tuned a tuning capacitor on it. I was running in the evenings, and at 20 watts it was starting to arc over. It was quite impressive. So there's quite a lot of voltage on the end of an end fed. You just got to watch out for that. Now, the end feds that you'll see typically on the internet, they use the coaxial cables. All right, go back to basics. Here we have an Anon, and I'll put it over here. And it's basically a transformer built with a ferrite core. And the concept is you take the very high impedance and you step it down to 50 ohms. But you also need a second conductor. Some people call it a counterpoise, I call it a radial, and the coaxial cable most often forms that counterpoise. If we could go back to the slides, please. Now, the end-fed half-wave is not really end-fed. It's fed close to the end. It's a good antenna for pedants, where we like to sort of say, no, that's not quite right, and argue about the decimal point, but it's not really end-fed. The last 20th of a wavelength is typically where the coaxial cable is connected, and it's typically, if you're going to put radials on, you make them 1/20th of a wavelength long. The coax, with that other arrangement I showed you, acts as the radial. Now there's current on the coax shield, because it's acting as a radial, and that, if it's draped on the ground, will be radiating into the ground, giving you quite happy and warm earthworms, contributing nothing to your signal. It's not much, it's a little bit. I work QRP and every watt matters, so for me it's been an exploration to try and get the best possible signal. Now, common mode current is the current on the shield or the outside of your coaxial cable. That flows along. When it gets to your transceiver, it can cause it to malfunction. I've seen transceivers reset themselves. If you're running a bit of power and you've got a lot of common mode current and you touch it, you can get an RF burn. That friend of mine, the first one I built him, he said it worked beautifully in his backyard on QRP, but on voice peaks it was giving it was very, very it was a terrible signal on voice peaks. It was because of the common mode. He had to put a 1-to-1 balun in the coaxial cable to tame it down, and he also had radials on there as well, and they were wrapped around the coax, so that was never going to end well. He separated them out, put a 1-to-1, and it worked a treat for him, and he's been using it ever since very happily. So the common mode current on the shield happens as a result of using that transformer, happens as a result of the proximity of the radiating element to the coax and the proximity of any radials to it as well. Now, same dipole, same height in the air, and if you look here, you can see I've fed it 1/20th of the way along. If you look at the gain pattern, and if you look just here, we've got the same gain. So all things being equal, if you mount your end-fed half wave the same as you mount a dipole, if your feed line and losses are the same, you will get the same signal. And that's about where it ends really, because almost nobody mounts them the same way they mount a dipole. I mount mine differently, we'll go into that. But that's at the heart of the end. If someone says they're fantastic, they do this, they do that, let them say it. It's no better than a dipole. It's the advantage of the end-fed half wave. Oh, sorry. I'll go into the advantages and disadvantages in a minute. The second harmonic, because it's end-fed, or near end-fed, we can run it. This one was 20 metres of wire, so it was cut for the 40 metre band. We can actually run it on 20 metres as well. And if you have a look at the current profile here, you can see it's a full wavelength on 20 metres. And the gain has gone up a fraction. But have a look at the pattern. It's showing us that it's a little bit better suited to DX perhaps. Not so good for local contacts. And it's also got a significant cloverleaf happening, which is pretty much impossible not to have when you go up in harmonics. But at the end of the day, you don't have to tune it. You can connect that one antenna through that one coupler, the Anon, and you can run it on multiple bands. And that's a massive advantage. You don't have to get up out of your chair, you don't have to twiddle anything, you just swap bands and away you go. Now, I typically run as an inverted L. I have a 10 metre squid pole, and I take it up to be 9 metres high because the top one's too flimsy. I have the feed point about 1.5 metres at the ground, and I run 2 radials. Why 2, you might ask? I found that the SWR is a little bit better. My modelling tells me that 1 is plenty. My analyzer tells me 2 is a little better. The gain pattern from that, look at it. I've dropped almost 4 dB, so something like half the signal coming out of it. And why is that? Like I said, it's not mounted the same as we mount a dipole. The ends are quite low. The saving grace is that the current point is getting fairly high in the air. On 20 metres, it's a little bit better, a little bit more gain, but it's not enough to get excited about. Now, how does that 3 dB of gain translate into received signal? It may be noticeable. 3 dB is approximately half the signal. You start to say, maybe it's a little bit, maybe it's not. At the end of the day, don't worry about it. What you've been able to do with the inverted L is to put an antenna up where you really probably struggle to get a dipole up. If you get a dipole up with similar mounting, you'll get the same signal, which was all the lead up to this. The inverted L, the sloper, the inverted V will all have similar signal because they've all got similar location to ground and similar heights. Here's the, I call it a flat L. Other people would call it a sloper. It's a sloper with altitude. Why would you mount something like that if you've got a house and you can't run a coaxial cable out to a tree or to a support, to a dipole or to another antenna? You can put the Anon on the wall and you can take the wire straight out. So that's a massive advantage. I've heard of people, don't want to go into this too much detail, but in a hotel room you can push a squid pole out a window with a wire on it and a very short radial out the window, and you can work that way. And as Tom said, if the hotel's big enough, you can drop the wire straight down the side. The only disadvantage is quite a lot of QRM, but it gives you another mounting option that you can't do with a dipole anywhere near as easily. And you still get a reasonable signal. You still get a it's actually a little bit better because it's a little bit higher. Okay, the inverted V, similar kind of signal, similar kind of pattern. I don't know if we've heard of Peter Parker, VK3YE, very popular amateur. He's in a lot on the YouTube. I saw one of his videos, saw him on the pier, I think it was at Chelsea, running exactly that, an inverted V. One point I will make is if you've got a 40 metre dipole, that's 20 metres of floor space you need to run it across for a dipole. If you're running an end-fed, it's less space because you've got a vertical component. With my 9 metre squid pole, I need about 12 metres of horizontal space, not 20. And that's an advantage for some people. It certainly is for me. And there we go. Why use an end-fed half-wave antenna? It's easier to set up. You can set it up where you probably struggle with a dipole. If you put a dipole up in the same way, you get the same signal. This is easier. The other thing is a lot less coax. You don't have to take the coax right up to the high that you would with a dipole or an off-center fed. I've used an off-center fed for many years and I like them very much. These are easier. And as I said before, for the multi-storey house, shorter coax, short radials, less horizontal space, as I mentioned. Multi-banded is a major plus. And they're easy enough to home brew. If you've got a few skills, not afraid of a soldering iron and winding some toroids, they're pretty easy. If you're interested in doing it, let me know. I've got articles I can give you and help you along. It's not an issue. Now, why not use an end-fed half-wave? One of the things is that since the antenna is closer to ground on one end, it's got a fairly intense E field. I haven't run the Panzer type calculations on it, but it will be intense. I like to run a few metres of coax to keep away from it. Here. The voltage on the end of the end-fed half-wave is quite high. We use enamel coppered wire to wind them. If you're running 400 watts into enamel coppered wire on a toroid, I have not done it, but I would suggest that you use Teflon coated wire and possibly coat the toroid because of flashover. We see the Americans running 1500 watts into enamelled wire. I think that's pretty brave. Voltage is not forgiving. The other thing I've been told is the QRM pickup. Because you've got the end of the antenna closer to ground, if you've got sources of QRM like caravan parks have been quoted to me by two amateurs. Infeed half-wave antennas struggle there because they're a bit closer to the source of noise. Solar inverters are not the amateur radio's friend. They kick up a lot of hash QRM. And I'd make the point too, what else works? Yeah, power supplies these days. Yeah, absolutely. And as I said there, that the feed point's near the source of noise. So if you're mounting that on the side of a house, if you've got a noisy house RF environment, yes, you'll get it into the antenna. You can treat that a little bit with one-to-one common mode balance here and there, and addressing the devices that are causing it, but be prepared for that. Now, there's a bit of a rule I've found with it, and it's helped my understanding, and that it's an antenna system. Everything matters. The coax and its length, more so than a dipole. It's not particularly fussy. You can choose a magic length and come unstuck with a dipole if you try hard, but if you run too short a coax, and that's acting as your counterpoise, it's not going to end well. It needs a certain amount of length. Whether or not you use radials, the radiator, how you mount it, its length, similar every antenna I suppose. And the Anon, its type and its efficiency. Yeah. Right, the components. We have pretty obviously the radiator. What we would normally call the antenna is a piece of wire. It's cut to half a wavelength long, so a 40 metre Infeed half wave is 20 metres long. There is a loaded version I have, which uses, pretty obviously, a loading coil. Now the advantage of the loading coil is obviously it shortens the antenna. That one is a total of about 22.5 metres long, and I run 80, 40, 20 and 10 on that, which isn't bad because normally you'd need 40 metres of wire. That's the advertising. The engineer's words on that are that you will lose about an S point of signal because of having that loading coil, so it's a little bit less in signal. And also the bandwidth is quite narrow, 50, 60, 70 kilohertz, something like that. But it does work well. I've done the AB antenna switch comparison to an Offcenter fed 80 metres, similarly mounted, about an S point down. So if you can't run the full 40 metres of wire on 80 metres, this will do the trick for you. If you could swap back to the slides, please. As I said, the coaxial cable matters, the radials. Now, if you're having common mode current issues, and it's a bit of a dirty little secret, not many people tell you about it, but you will need, and I would advise to run a one-to-one balun in there somewhere. I have a number here to show simple baluns that you can make with J-car cores that work surprisingly well. And the last point on the slide there is, if you've got an end-fed Anon, or you've got the Anon connected to your antenna and you've got a bit of coax and you've got a one-to-one balun, what happens if you put that one-to-one in the same box? Not seen it done on the internet. I'm sure someone's done it. I just haven't looked hard enough. And here's two of them. They're both built with J-car cores. The top one there is a single core, and that comes in high 80% efficiency. The Anon is on the left-hand side. The one-to-one is on the right-hand side. The one-to-one isolates the coax from the Anon. It reduces your common mode current. I've measured it. by at least 10 to 1. I felt a bit disappointed in that. I thought it should have been more because the 1 to 1 really is quite a good one. The reason is pickup on the coaxial cable from being so close to the antenna, but at the end of the day I can run that without another 1 to 1 in the cable. It makes a one piece of kit that you can use to set up your antenna. The version at the bottom uses a stacked pair of cores. I'll go into that a little bit later. I did that to enhance the low end performance for 160 through to 20. It's terrible on 10, but from 160 through to 20 it's extremely efficient. Back to the slides, please. Difference if you have the 1 to 1, 1/20th of a wavelength down the coax. If you're running the hybrid, you still need radials. If you're not running a hybrid, it's probably a good place to have it. So the answer would be yes. What I think happens when you're using the coaxial cable with just the Anon, not a 1 to 1, I think a bit of loss happens, and it's a bit like a fan dipole where it finds the best impedance and uses it. You'll find your SWR is a little better. Okay, that's what I've found on the tests I've done. Having the 1 to 1 in there, the SWR is not quite as good. The common mode current is a lot less. And SWR is pretty much a terrible indicator of the efficiency of your antenna. A good question though. Yeah, I would suggest you run one anyway, particularly if you run 100 watts. I've got the ICOM 703's got an auto tuner in it. If you've got an auto tuner in your radio, I think they tend to tame the common mode current a little bit because of the inductors in there. I've also got an 897D that hadn't got a tuner, and that does not like common mode current. Straight into the back end of it, it does not like that at all.
Got a question from Sue?
Sorry, which?
Question from Sue? Yeah. So, question from Sue? So, Eric...
Oh, sorry, I didn't see it. I
Yep.
can't read it.
That's fine, I can read it to you, if you can hear me.
I have a high Q tank circuit, about ceiling height Infeed antenna off top of coax, tap down the inductor band. Okay, so what you're doing is basically inductively coupling it. It's a similar sort of thing to what we're doing, and in fact, in a minute I'll bring up the circuit diagram to the Unan, and that's pretty much what we're doing. I would call that an auto tuner. If it's got a high Q, it's probably very good, I would have thought. You probably find a nice 50 ohm match with the tapping, and also where the antenna's off the top. Yeah, no, I wouldn't offer any criticism of that at all. It should work really quite well. Yeah, yeah. Look, the old link couplers, there's nothing wrong with them at all. The disadvantage, though, comes in portable use. Where is it? This one, I'll just pop it on the mat. Wrapped up inside that bundle of wire is the Anon with a 1 to 1. It's a hybrid balun inside. I run 50 watts of sideband through it. That's the little coupling unit, the hybrid beside it. You can literally put that in your pocket. Doing that with the old link couplers is probably not going to end well. It all comes back to portable operation, throwing it into your go bag. What I actually do, you see people gently unwinding their coax. I actually unwinding their antenna off the winder. I find if I just hold it in the air and just keep pulling it. It stays in the air and it unravels in the air for me. It's a little bit rough and ready, but it does work well. No, the high-Q tank circuit is certainly a good option, but for me, I'm all about portable operation, and some people run them, bolt them to the side of the house. The other thing I would mention that would probably mean that you're running the antenna through the house or through the wall or something like that to get to your tank circuit. I'd be a little bit nervous of the high voltage there and possibly any QRM pickup. You try and keep it away from the house if you can. I know my wife's monitor on her computer. It certainly doesn't like it when I transmit on 100 watts with the Infeed. It probably needs another extra 1-to-1. Oh, back to the slides, please. What I like about it, pretty obviously, simple installation. I play portable. I don't have a permanent antenna set up. I set up in the backyard. I've got a little bit of space at the front. Squid pole is my preference. I was talking to someone else tonight, and they like trees. You literally throw the antenna over a tree branch, and you're up and going, and it's a 5-minute job. And you've got the sloper inverted Vs, all that sort of thing. Easier than a dipole, and quite often low mounted and still good. So I've gone over the same thing a few times there. Yeah, Tom's made the point that trees, quite often you find more trees, and carrying a squid pole around, it's 1 metre long, and it can be a bit tricky, particularly on a bicycle. I work in a car though. If you're a SOTA operator and there's trees on the mount, it's probably a better option for you. Tom suggested there may be better signal. I wouldn't be surprised if there's better signal, but at the end of the day you're just trying to make some contacts on SOTA, and I think both would probably work quite well. My friend Craig, he runs surprisingly low mounted on tree branches, 3, 4, 5 metres in the air for a 40 metre Infeed, and it works very well for him. What I don't like about it is the, I seem to have gone past, what I don't like about them is using the coax as a radial. I've never liked that. It's uncontrolled. You've got common mode current on it, and you've got quite often a fair amount of it, and it's length dependent, which is why I developed the hybrid Unan and use radials. Many of the Unan designs are quite lossy, and we'll head into that in a minute. Here's our picture, and for the person on Zoom, you're probably on the right-hand side, possibly, where you've got a tapped inductor. It's a good way of doing it, with or without the tuning capacitor. As I mentioned, I used the tuning capacitor version about 10 or 15 years ago, and at 20 watts the cap was arcing over. It was a broadcast cap, so it was no great surprise. The Anons I've been making are the left-hand side kind version, where there's a capacitor across the coaxial cable, and that helps to tame the impedance a little bit, particularly at the higher bands. The number of turns on there, the ratio is either 7-to-1 or 8-to-1, and sometimes a little bit in between. If you're running just an Anon and you're running coaxial cable, the 7-to-1 seems to work better. If you're running a 1-to-1 balun in the same box as a hybrid, I've found the 64-to-1 works a little better. It's a slightly higher impedance, and it seems to work a little better. There's plenty of varieties. There's a couple of other options. I've seen them with switches in the bottom. I've seen them with separate primaries, auto-tuners. I've seen L-matches used. Peter YE uses an L-match, I believe. My only concern would be to watch out for high voltages. If you've got the Infeed coming straight off onto a capacitor, you need quite a high voltage capacitor. And the other point I'd make is that not all capacitors are created equally. There's some 6 kV caps you can buy from a local electronics store. They're blue and they're rubbish. They have more loss than the Anon itself. I've tested them. Silver mica is probably one of the better ways of going. Now, notes on loss. The conventional Unan and the coax on the grain will give you a better SWI. I did make that point before. Part of it is I think there's a little bit more loss. And you're basically approaching a dummy load in kinds of loss. The more lossy it is, the better your SWR will be. SWR is not really an indication of performance. Also, the coax on the ground, uncontrolled, it's going to be changing your patterns a little bit, and good luck with common mode current. The problem with radials is it's one extra thing. They take a little bit extra time to set up. They're a tripping hazard, which is never good at my age, and they will give better system performance, I believe. So they are, I believe, worthwhile, but you just got to bear in mind those little things. Now, the internet, when I got into looking at Unans, it's a mixed blessing. It really is. There's so many YouTube videos on making an Unan, and I'll put the one that you'll see most often. That's commonly, it's an FT240-43. It's 2.4 inches in diameter. It's the 43 mix of material. It has the primary separated from the secondary. The primary is wrapped around the secondary. It's 2 turns. The secondary is 14 turns, so it's 7 to 1, approximately 49 to 1 impedance transformation. They spread the turns out and they have a crossover in there. There is, and I'll say this most definitely, absolutely no reason for doing any of that other than to generate a little bit more loss. I've measured that versus winding it as an auto transformer. There's a couple of percentage points loss because of doing it that way. It seems to be something that's been passed down in ham law. Here's the alternative version. All the turns are compressed together and it's a bit hard to see. But there are 3 turns on the primary, and it's a total of 21 turns tapped at 3 turns. It's called an auto transformer. Instead of 2 and 14, 3 and 21 halves your losses. That's going to mean pretty much nothing in terms of your signal strength, maybe 0.2 of a dB difference improvement. But the heating involved, if you're running digital, will be a most significant and worthwhile improvement. If we could go back to the slides, please. Now, the point I was making there, that most designs you'll see on YouTube show how to wind that core with the spaced out turns. They're not great. It's seldom optimised like I've done, and it's extremely rare to see any curves for loss over frequency until tonight. And the other point I will make is that you see these amateurs put one of these things up in the air and they make hundreds of contacts literally. And I would make the point that the American experience with a number of amateur operators over there is very different to what we have here in Australia. And quite often disappointment follows hope. I found that myself. I was doing testing on these things and I thought, gee, this is the 2 and 14, the spread out turns, that's what the ARRL recommends and puts in their kit. And I thought, gee, it's going to be good. Now, before we get to the curves, does the loss in the Unan matter? I've touched on that. Digital versus sideband and the ability to detect the difference, you're going to struggle. Pure and simple. Heating is where it's at. If you're running 50 watts of sideband or 50 watts of digital, with that other design, I'll go into that in a second, but it is going to be a significant difference. How much loss are we talking about? The improved version I've got, I showed you there, has better than half the loss. So it's going to be about a half a dB of difference. When I said before 3 dB you can just hear, you'll never hear half a dB of difference, like I said. And down the bottom, Unan loss is all about heating under power. That tiny weeny little coupler I showed you before, hybrid version, I put 50 watts of sideband into that. It's quite happy. The other point I'd make is that the loss in your coax can be higher than the loss in your Anon. And the antenna gain, if you push your antenna up a couple of metres higher, that will make up for any difference, much more so. A couple of examples. I wrote some software to calculate the heating under various types of toroids, various amounts of power and efficiency. Now, the first ARRL version is around about 80% efficient on a good day. If you put 50 watts of digital into that for 5 minutes, you should expect somewhere around about 35 degrees C of heat rise. If you're running that at sideband, maybe 7 degrees. That's the difference between the two modes. Like I said, you'll never hear it in signal, but in heating it can be an issue. And you need to remember that the Unans in a box with very limited heat, with very limited airflow. So if you've got running FT8 for an hour or something at 50 watts, it could get steamy. And the other thing is they get hotter, they get more lossy, so it'll accelerate. Now, in the testing, I think the next slide's on the curves, but you've got to define what we're looking for. Now, there are 4 methods, and the other thing I would make is the reality of the measurements. There are 4 measurements I've done for measuring loss in an Anon. The first one is you just put a link on it, you measure its resistance with a VNA and you run a formula and you can get the efficiency that way. I've actually tested that against other methods and it's extremely good in the mid part of the bands. On 40 and 20 metres it comes very close. It falls apart on 10 metres and 80 and 160. The second method is to put 2 Unans back to back and you measure the through loss, which sounds like a great idea, but you're operating into a load that will never be seen in real life, so it's not indicative of what your antenna is going to be seeing. The third one is to terminate your Anon in its characteristic impedance, in other words 2450 ohms, and you measure what comes out the back end. Apply a formula, you get the loss that way. Again, it's not really indicative of how your antenna is going to be, but it's actually got an advantage that you only need to build one. It's simple and it's quick, and I've focused on that one. Test number 3. Test number 4 I've done a few of, and it takes quite a while. You put a temperature sensor onto the core, you energise it for a certain amount of time, you calculate the amount of energy going into the core, the heating of the core, look at the difference, and you can calculate the efficiency that way. Test number 4. The other thing about the measuring is if your antenna's not perfect one-to-one, it'll have a reactive component that will be changing your efficiency. And I go right back at the very top, the reality of what you're producing. What number best represents how the antenna, the Anon, is performing? Probably number 4 is the best. Now here's actual component testing curves. The reddy orange curve is from that ARRL toroid, 2 turns primary, 14 turns secondary, and as you can see it's significantly less than 80% at 160 metres. It rises to be mid-80s at best and it drops down at the top at 10 metres. It's a reasonable all-round performer, not great anywhere. If you use that J-car core, the biggest one, the LO1238, yes, I got that right, and you use a 3-turn primary, your loss is better than half. So all of a sudden you've got a lot less heating. The graphs are not particularly fair because they are 2 different winding styles, 2 different cores, but that's an indication. And I've also used that FT240 core in the following graphs so that you can compare other designs to it. What happens if you put a 3-turn primary on that FT240 core? The answer is your loss is far, far less, up to 21 metres, or up to 20 metres really. It really does change the whole equation dramatically. But if you have a look at 10 metres, it's a bit tragic. I wouldn't suggest you run it there. You're going to be dissipating a fair amount of heat into your core if you're running digital. Sideband is probably fine. But if you're running digital modes with that particular core, going to a 3-turn primary, that's going to be a big advantage up to 20 metres. And what about other cores? I've literally got dozens of different windings. This is just a bit of a cherry pick. The various cores, you can see the orange core there, which had the 3-turn. The orange core there, in fact, is 2 of the J-car cores. And that has got the least loss of any that I've tested. You see it's approaching 100%. And as soon as you see that, the red flag must rise, that the testing method possibly is not terribly indicative. It should not be that efficient. But those are the numbers I got. The brown is that ARRL one. The yeah, there we go. This one, the greeny one, is that little tiny core that I showed before, that I run at 50 watts, and you can see what a great performer that is. Quite low loss. So not all Anons are created equal. Power rating, size, how you're going to run it. If you're a SOTA operator, you want small and lightweight. That little tiny weeny cores that I showed you is the way to go. You wouldn't run the ARRL version. And at 160 as well, you need to make sure that you've got the right kind of efficiency there if you can get it. And next is the hybrid Unans, which I've touched on. It adds a 1-to-1 into the same box. You must use radials, reduces your common mode current by a factor of 10 in reality. The coaxial cable, if you couple put your coaxial cable onto an antenna analyzer. If you've got a conventional Anon, if you touch the coax, the SWR will change. And the reason is that you're changing the whole dynamic of the system. If you've got a 1-to-1 in there, it hardly makes any difference at all, if any. So it reduces the effect of the coax on the tuning of your antenna. And as I've said, there are far less issues with common mode current. The disadvantage of having the 1-to-1 in there, it's a bigger box, it's going to be a bit heavier. But I think that's all outweighed because it's easy. You just throw one box into your go bag or into your pocket and away you go. And here's a practical 1-to-1 hybrid Anon, which I have here somewhere. And here's how you make it. You get some J-car cores, stack them as shown, wind them as shown, and you will get the kind of performance. In fact, these are the LO1234 cores. I'll go back and I'll show you the losses for that one. LO1234 cores are the yellow line. On 10 metres where it's worst, it's better than the ARRL design. I haven't tested it at 160, but from 80 through to basically 15 metres, it works extremely well. And you can put 100 watts into that very, very easily and happily. I'll go back. Basically, you stack 2 cores, super glue them together, and wind them as shown. I goes 24 turns, tapped at 3. That's my Anon. And I usually use about 9 turns of bifilar, and that's my 1-to-1. Hook it up with a silver mica cap, add the radiator and the radials, and it's done. I'll just have a look. I brought one with me. There it is there. From the size of it, it fits in your pocket. It has an advantage that it's easily maintainable. It's quite cheap to make. 20 bucks, 30 bucks would see it out completely, particularly if you use your club discount at the electronic shops. And it takes an hour or two to build. I have other versions of that, and that's precisely the same cores built into a piece of plumbing tube, 40 millimetres in diameter, I think, approximately. And above it is the actual cores put on a 3D printed sled to make it easy to put together. In hindsight, the tube is a horrible thing to make. It takes quite a while. The simple box does work, does go together a lot easier, but you can't wind the wire onto the box. So I made a wire. Oh, I'll shift it. So I made a simple cable tidy that you can wind the wire onto that. I'm still not convinced it's a great product, but there it is. Oh, sorry, if we could go back to the slides, please. And there's the curves for that particular set of cores. As you can see, at 10 metres, it's starting to dip, but it's still better than the ARRL version. And everywhere else, it's far, far less loss. How do you make the radiator? It's simplicity itself. Take the longest wavelength that you're going to work. If you want to work 40 through 10, cut your wire to be half a wavelength. So it needs to be, 20 metres long. There's the examples. Now, of the loading coil version I did show you before, that allows you to shorten the radiator to be just 22.5 metres long. Now, I was talking to somebody else tonight, and I said, I asked him what bands he runs, and he said 40 and 20, and I said, if you get it tuned to 40 metres, how's the tuning on 20? And he said, not good, and 10's worse. What it does is it wanders out of band because of the capacitive end effect of the antenna. The way you can fix that is to have a very small loading coil added to the radiator, 2 metres up from the feed point, and that brings all your bands into resonance, and you can get it quite good. You can set it up to 7.1, 14.1, you know, somewhere up in 28, 29 meg, and you can make them all line up. Without that, you can sort of struggle. 20 metres can be quite high, almost out of band, and 10 metres it can be way out. The loading coil is very small. It's only about 8 or 9 turns on a 20 millimetre former, and here's one here. They call that a compensation coil, and it just helps you line the bands up. Back to the slides, please. The radiator. Oh, now, if you're running a conventional Anon, radials are optional. The coax will do the job for you. They're mandatory for a hybrid, and they're 1/20th of the wavelength. So, for the 40 metre, 20 metre, 10 metre band Infeed, you need 2 metre long radials, or one of them or two of them. I've actually run 80 metres on my Infeed, and I found if I added, the radials had to be 4 metres long. I also put a 2 metre radial on there, and it really helped the 20 metre SWR. It brought it right down for me. Radials, keep them away from the coax, and I found 2 work slightly better, SW1-wise. Band creep. You probably can't remember, but if you looked at the current profiles previously, because there's more current closer to the feed point as you go up in frequency, the compensation coil pulls the resonance down more as you go up in the band. And as I mentioned, if you remember the charts, I won't go back to them right now, but that's the way the compensation coil works. On 80 metres you have the lowest current at the feed point. On 20 metres it's a little bit further along the wavelength, so there's a little bit more current, so the compensation coil pulls it down a little bit more on 15 and 10. And yeah, we've talked about that. 8 or 9 turns on that small former. Oh, it's worth, if you're interested in it, Steve Ellington on YouTube. He's got a great set of, he's got a great video. He does all the numbers for the compensation coil, different bands, how much it pulls them down by. Another person is Ball 3, Hotel November, is it? Worthwhile, good. Common mode current, touched on that before. It's the radiation on the shield of your coax. This is where a dipole beats an Infeed. There's usually less. Infeed has a little bit more, so you do need to be aware of it. You're not in control of the common mode current unless you do something about it. Different coax lengths will generate more or less. Proximity of the coax to the antenna and the radials will affect it, and it will affect the pattern. And it gets into your transceiver, as I mentioned before. Treating it, pretty simple. You put a 1-to-1 in the coax, some distance from the Unan. I think that was mentioned before. It's a good thing to do. How far? I would have said at least 5 metres from it. If you're running the coax as only the radial, you probably want at least 5 metres of coax. You won't eliminate it, but you will reduce it dramatically. The hybrid Unans already got one in there. And at the bottom there, it's quite right. Common mode current is sneaky. It gets in everywhere. And finally, the Infeed is a good general purpose antenna. If you mount it the same as a dipole, you'll get the same signal. It's multi-banded, which you can't do with a dipole. It's a lot better installation options. There are some issues, common mode current, radials, 1-to-1s, things like that. They're not hard. They're really, really not hard. I've got some gear on the bench here you can come up and have a look at, you can make yourself. Unans, for the OCD, obsessive compulsive amongst us, and I think I am one of those, we can focus on them too much. They won't make much difference to your signal at all. If you use the lossiest one to the best one, you'll probably never hear the difference. If you're running digital modes, that's when you should start to be a bit concerned. And it's no surprise they're popular. Every time I come up on air, about a half to a third of the people I talk to have one. I'm a little bit concerned about running them as a home station because of QRM pickup, but they're still very popular for that. Any questions? Thank you all.
Brilliant, Richard. Roger's got a question. What's your question, Roger?
So Roger says shortened quarter wave stub for 10 metre and higher is a good option.
Yeah, probably is. It's probably more efficient too. The Unans I've shown tonight really do struggle at 10 metres. These have been the simple Unans. There are different winding patterns where you wind the primary over the top of, physically on top of the secondary, can help with efficiency. Also, the geometry of the core matters. If you look at the FT240, it's similar to a bicycle wheel where it's It's got the core material on the outside and it's got a great big hole in the middle, and it's not very tall. As soon as you stack two cores together and then you reduce the diameter of them, you make them considerably more efficient. In technical terms, the amount of impedance you get per turn increases, so you can get away with possibly less turns, less loss because of those turns, and the magnetic path favours the higher frequencies a little better. For any of the homebrew constructors, from what I've seen so far, quite often in multi-stage transmitters where you couple one stage to another with a toroid, if you stack a pair of toroids, you can get significantly more signal, if it matters, in there, like 20-30% more signal just by changing the geometry of the toroid. And in finals, in a lot of transmitters, you'll see them using ferrite sleeves, which are quite long. And the reason is the same. They're much more efficient with that geometry. Sorry. Roger, yeah, you're probably very right. Quarter wave stubs would work quite well.
All right. I think that does it for this evening, Richard. On behalf of EMDRC, I'd like to thank you very warmly for your time this evening, and no doubt hundreds of hours of research working through the elusive subject of antennas and ability to get your signal out. So thank you very much. Much appreciated.